Powered Parachute Handbook 9-1 Ground Reference Maneuvers. Greetings, aviators, as we venture into the realm of ground reference maneuvers, a vital component in cultivating a high level of pilot proficiency. While these maneuvers may not find routine application in day-to-day flying, the principles embedded within them extend their relevance to various pilot operations. They serve as a compass, guiding pilots in understanding the interplay between the powered parachute and external forces, fostering a refined control touch and the necessary attention division crucial for precise and safe powered parachute maneuvering. The initial phase of pilot training revolves around technique development, maneuver comprehension, and mastering the art of handling the powered parachute. A pilot's attention is dedicated to mastering the physical intricacies of flight. However, as proficiency is achieved, an essential transition unfolds. Upon mastering fundamental maneuvers, the time has come to introduce pilots to tasks requiring external attention. This shift is vital to prevent fixation, a habit that, if prolonged, could compromise ease and safety in a pilot's journey. Breaking this fixed habit, once established, proves to be challenging. Hence, the need for a timely introduction to maneuvers that encourage practical application, guiding pilots to extend their focus beyond the cockpit. Ground reference maneuvers unfold as a delicate orchestration, executed at low altitudes with meticulous correction for wind drift, tracing a predetermined path over the Earth's tapestry. These maneuvers forge the ability to wield the powered parachute with finesse, correcting for wind dynamics while seamlessly juggling other critical factors. A pilot's gaze extends to the horizon, aligning with ground objects, executing precise headings, and maintaining vigilant awareness of nearby air traffic. Before commencing these aerial maneuvers, a ceremonial clearing turn takes center stage, an aviation ritual ensuring a collision-free canvas for the impending maneuvers. Clearing turns, a strategic choreography of 90-degree turns, ward off potential encroachments into another aircraft's realm. A pilot's training program may introduce variations, but the essence lies in adopting an effective clearing procedure, a symphony of turns and vigilant visual scans sculpting a safety strategy. Navigating this aerial realm mandates an altitude balance, not dipping below 200 feet AGL, while also steering clear of any person, vessel, vehicle, or structure by at least 500 feet. The radius of turns, the drift correction, and altitude management form a seamless performance, with changes adapting to circumstantial demands. In this orchestrated spectacle, both instructor and student become navigators and performers, attuned to potential forced landing fields. These fields, strategically chosen to minimize community, livestock, or public hazards, represent a lifeline in case of unforeseen challenges. The altitudes at which these maneuvers unfold leave minimal room for field scouting, urging a preemptive selection. Much like a boat navigating upstream against a swift current, a powered parachute, once airborne, becomes subject to the forces of the air mass. This interplay with the surrounding medium necessitates strategic adjustments to maintain the desired ground track. If the river flows calmly, the boat can chart a direct course to its destination without drifting. However, if the river's current is swift, the boat must counteract the downstream flow by steering upstream. Analogously, a powered parachute aligns with a road, occasionally drifting closer or farther without any intentional turn, signaling the lateral movement of the air mass. The powered parachute drifts in harmony with the wind, akin to the boat's interaction with the river current. When navigating straight and level along a chosen ground track, correcting for wind drift involves steering into the wind sufficiently. This aligns the powered parachute's movement with the wind, countering the lateral drift. The correction angle may vary based on wind velocity, requiring adept piloting skills. Consider a scenario where a powered parachute encounters a 30-knot crosswind for an hour. The air mass, drifting 30 nautical miles to the right, propels the powered parachute in tandem. It moves forward but also drifts 30 nautical miles to the right concerning the ground. The drift correction strategy becomes pivotal to maintain the intended ground track. In turns, the wind exerts varying forces due to changing angles. During the upwind portion of a turn, the powered parachute must compensate by turning more steeply, countering the drift. Conversely, during the downwind segment, a shallower bank and slower rate of turn become imperative to harmonize with the wind forces. The principles of adapting bank angles and wind correction angles persist across all ground track maneuvers involving directional changes. In an ideal scenario devoid of wind, executing a constant radius turn with an arc of 180 degrees should be straightforward. However, the real-world interplay of constant banking and wind introduces complexities. For instance, a constant angle of bank during a turn with a crosswind may result in a distorted ground track, deviating from the intended semicircular path. Pilot finesse comes into play, as adjustments are made to neutralize wind effects, ensuring a constant radius semicircle over the ground. The powered parachute returns to the starting point but, owing to wind influence, may be slightly downwind. Similar demonstrations with reference lines parallel or perpendicular to the wind highlight the significance of pilot adjustments in achieving the desired ground track. Through these revelations, we discern the delicate interplay of pilot skill, wind dynamics, and strategic maneuvering. The principles articulated here serve as the cornerstone for mastering ground reference maneuvers and ensuring precise control within the ever-changing embrace of the skies.